Hello everyone, welcome to lesson 3 of Mastering Ethereum. Today we will explore the fascinating world of Ethereum. Ethereum is an advanced blockchain platform that allows developers to build decentralized applications and execute smart contracts. It allows developers to build and deploy distributed applications that run on a peer-to-peer network without the need for a centralized authority. Let's understand what is Ethereum, how it works, its application, and use cases in a much more detailed way. Think of Ethereum as a global decentralized computer network. Unlike a traditional computer, Ethereum is not controlled by any single entity and operates on a blockchain to securely record transactions. It is programmable, one can write smart contracts on it using Solidity language. We will learn more about smart contracts in detail later. Ethereum and Bitcoin are two most well-known cryptocurrencies, but they serve different purposes. Bitcoin is designed as a digital currency and functions primarily as a simple payment network. On the other hand, Ethereum is programmable blockchain, enabling a wide range of functionalities beyond just payments. Bitcoin works on proof of work consensus mechanism, while Ethereum has just shifted to proof of stake consensus mechanism with the Ethereum 2.0 upgrade. A key feature of Ethereum is its ability to execute smart contracts. A smart contract is a self-executing contract where the terms are written directly into the code. When predefined conditions are met, the contract automatically executes without the need for a middleman. Let us understand this with the help of an example. You wish to set up a lemonade stand. You write down the rules in a smart contract. For example, the price of one cup of lemonade is $1. When someone comes to buy a lemonade and puts $1 into a special machine connected to your stand, the smart contract automatically checks if they paid enough. If they paid $1, the smart contract releases the cup of lemonade to them. If they paid less or more, it won't release the lemonade and it will tell them to adjust the payment. Let us now see how smart contract works. Two or more parties agree on the terms and conditions. The contract executes automatically when the conditions are met. The transaction is completed without requiring a third party, thus minimizing trust issues. Critical to the operation of Ethereum is the Ethereum Virtual Machine or EVM. This is the environment where smart contracts run. A significant advantage of EVM is its consistency and versatility. It ensures that the same code runs identically across all nodes in the network, and it is Turing complete, meaning it can solve any computational problem given the correct resources. The EVM provides for a secure and isolated environment for smart contract execution, protecting the network from malicious and buggy code. The cryptocurrency used on the Ethereum network is called Ether or ETH. Ether is utilized to pay for transaction fees and services on the Ethereum network. Miners, individuals who validate transactions and maintain blockchain, are rewarded with Ether for their effort. Ether can be stored in digital wallets and be used to pay for Ethereum-based transactions and services. It is an essential component of Ethereum ecosystem, powering the network's decentralized functionality. Developers can create dApps or decentralized applications using Ethereum. These applications run on blockchain or peer-to-peer network and utilize smart contracts for their logic. They offer decentralized storage and are open source, meaning they are not controlled by any central authority. These were some key features specific to Ethereum. Now let us look into Ethereum's history. Ethereum was conceived by Vitalik Buterin in 2013. Deployment began in 2014 with widespread community involvement, and Ethereum mainnet was launched on 30th July 2015. Ethereum enables numerous use cases. DeFi applications allow for decentralized financial services. NFTs and digital collectibles can be created and traded. Ethereum enables creation of custom tokens which can represent assets like real estate, stocks, or even collectibles. These tokens can be traded, transferred, or used within decentralized applications. Products can be tracked from their source to consumers, helping in supply chain management. Ethereum-based blockchain games and NFT platforms allow players to own, buy, and sell trade in-game assets securely. Let us discuss the benefits of Ethereum. There is no middleman required, which reduces the need to trust third parties, hence enabling trustlessness. All transactions are publicly recorded on blockchain, ensuring transparency. Data on blockchain cannot be altered once recorded, ensuring immutability. Due to its decentralized nature, Ethereum is highly resistant to hacking. The Ethereum development process involves writing a smart contract using Solidity language, which are then tested locally on a local Ethereum node. and then the validated contracts are deployed on the main network. The Ethereum platform uses two types of accounts: externally owned accounts and contract accounts. Externally owned accounts, or EOAs, these accounts are controlled by private keys and are used by human users to interact with Ethereum network. Contract accounts are accounts that are controlled by the code and are used to deploy and execute smart contracts on Ethereum blockchain. Ethereum clients are essential software implementations that allow users to interact with Ethereum network. Here's an elaboration on different Ethereum clients. Geth, also the short form of Go Ethereum, is a Go implementation of Ethereum protocol. It is one of the most widely used Ethereum clients and is known for its reliability and performance. Geth provides a command line interface for interacting with Ethereum network. Parity. Parity is a Rust-based Ethereum client developed by Parity Technologies. It offers a user-friendly interface and is known for its efficiency and security features. Parity supports features such as Ethereum improvement proposals and multisig wallets. Apart from Geth and Parity, there are several other Ethereum clients like Ethereum J and Nethermind. Each client may have distinct features, performance, and characteristics. Developers and users can choose the client that best suits their needs and preferences. When choosing an Ethereum client, consider factors such as ease of use, security measures, compatibility with your operating system, and the specific features or tools you require. Ethereum is continuously evolving with several phases. Phase 0, or the beacon chain phase, is phase that marks introduction of beacon chain, which is crucial for transitioning from proof of work to proof of stake. The beacon chain runs in parallel with existing Ethereum proof-of-work chain and introduces the proof-of-stake consensus mechanism. Phase 1, or the shard chain's introduction. Sharding is a key upgrade aimed at improving the scalability of Ethereum. In Phase 1, the network will be partitioned into multiple smaller chains known as shards. Each shard operates independently, processing its own transaction and smart contracts. Execution environments on shard chains, which is Phase 2. Phase 2 makes shard chains fully functional by enabling the execution of smart contracts and transactions. Cross-shard contract calls is Phase 3. The final phase in the current roadmap enables cross-shard contract calls, allowing smart contracts on different shards to communicate and interact with each other. Ethereum currently uses the proof of work for consensus and mining, but it is transitioning to proof of stake, which is more energy efficient and environmentally friendly. This change from proof of work to proof of stake is known as the merge, which is brought about by phase 0. Ethereum Improvement Proposals, or EIPs, are standards that propose new features, improvements, or modifications to Ethereum. They go through rigorous discussion and review before being approved. Some notable EIPs include EIP 1559, which introduces a fee market reform that significantly changes the way transaction fees are managed, aiming to make fees more predictable. EIP 3675 proposes significant upgrades to Ethereum, facilitating the shift towards proof-of-stake consensus mechanism. In addition to main phases, various layer 2 scaling solutions are being developed and implemented to further enhance Ethereum's capabilities. State channels allow transactions to be conducted off-chain, only requiring on-chain updates when necessary. Plasma chains create smaller scalable versions of Ethereum blockchain that can handle specific applications. Rollups batch multiple transactions into single one to reduce the load on the Ethereum mainnet. Sharding splits the network into multiple shards to process transactions in parallel as discussed earlier. Benefits of Ethereum include its trustless nature, where no third parties are needed to enforce agreements, its transparency with all transactions recorded publicly, its immutability ensuring data cannot be altered, and its high level of security owing to decentralization, cryptographic security, and economic incentives given to validators. This flowchart depicts Ethereum's combined security model. The system may be divided into two parts: the deployed operating network, which works in mechanical way according to set of objective rules, and social layer, which is the sum of people who develop and run the operating network on a global scale. The model is combined because it addresses the security of operating network by using proof of work as physical component and security of social layer by using coordination problem as a political component. In other words, proof of work makes it very costly to attack the system computationally, and coordination problem makes it very costly to attack the system socially. The Ethereum ecosystem is vibrant and expanding, supported by a large community of developers and many innovative projects. Comprehensive development tools make it easier for new developers to get started with creating the apps and working with smart contracts. To start developing with Ethereum, you must learn Solidity, which is primary language for writing smart contracts. Install Ethereum clients like Geth or Parity and development tools. Join community and participate in forums, events, and contribute to open source projects. Create and deploy your own decentralized applications. One such DApp will be made by us further in this course. With this, we come to the end of this lecture. Thank you for joining me in this introduction to Ethereum.